So last time we started talking about percent, and in particular we had run into a few things. Let me just give you a real quick recap. We had talked about the fact that there's several ways to change numbers into percents or percentages, right? And it's not always just moving decimals that are convenient. In fact, sometimes proportions are convenient because they're actually fractions that we're turning into a percent. And then the other thing that we had done last time is we had looked at, where was I trying to go? Over here, primarily anyway, was taking a look at three different applications of percent problems. So one was finding a percent of a number, so something like what is 15% of $32. One is finding a percent one number is of another number, in other words, finding the percent. And then the third one was finding a number when a percent of that number was known. So something like 13 is 45% of what number? And we had seen three applications, one of each type. So in this case, we had talked about finding a value when we knew the original price, and we wanted to know what the sales price was, right? What we're going to actually have to pay. On this one, we had a ski resort that had a percentage of their runs open, and then we were wanting to know, well, how many runs do they have? And then this last one was one where we were trying to figure out how much the price of the house increased over time, and so we were finding the percent that went up. This one. So we're going to take a look in this last this last material. Sorry, I'm trying to clean that off. And we're going to be taking a look at a few things. So some of them are mental math. And then some of them are some interest situations. That's kind of what's left in this section. So mental math is one of those tricky things. So those of you who've had me before, and we've done mental math before together, you'll remember me saying this before. Mental math means it's something you should be able to do in your head. But you have to do something on paper so I know what happened in your head, right? So it sounds like I'm sort of, telling you have to do things in a way that I'm not really intending that you do them. So a general rule of thumb is that if you can't do something in 3 steps, it's not mental math. Now you potentially, because you guys, are a little older, are going to be able to do more than 3 steps in your head. But this content is meant for that later elementary to early middle school kind of grades, and doing more than 3 steps in your head isn't really very practical, at least not for the majority of students. So we're kind of banking on 3 steps as kind of our maximum amount that we're going to be able to say is really mental math. Okay? So we've got a couple of examples here, 3 of them, I think. And the first one says we're going to find what 15% of $42 is. So it's really nice to find things that are worth 10%. Why is 10% such a nice number to find a percent for? It being even is helpful. I think there's more to it than that, though.
You could just move the decimal place over.
Yeah, it's something specifically about the fact that it ends in 0, right? 10%, I know this says 15, but check with me for a second here, right? So 10% means it just moved the decimal. So if I wanted to do 10% of 42, what would it be? Yeah, it'd be 4.2. Okay, we just moved the decimal over. So 10% is part of 15. What's the other part that it needs to have? 5%. So if I know that 10% is 4.2, how can I find 5%? Half it. So 5% would simply be half of 4.2, which would give me, 2.1. So if 5% is 2.1 and 10% is 4.2, what is the last thing that I would need to do to find 15%? Add them up. So we add these together and we'll get 6.3. Do you see, and it's dollars, we'll put that clearly, and a 0 here at the end. Do you see 3 steps in what we just did? Yeah, it was a 3-step problem. We found the 10%, we found the 5%, and we added them up. So there's our 3 steps that would work for this. So thinking along those same lines, there's a couple different ways we could do this next one, but I think there's one that sort of naturally presents itself. What could I do to find 20%? Okay, I can do 10%. So 10% of 280 would be what? 28. And then I've got a couple of options. What could I do next? Yeah, I could just multiply it by 2. Or what could I do? You could add it to itself. So you can either multiply by 2, Brooke had said, which is 56, or you can add it to itself and get your 56. This was a 2-step problem, right? Not even 3, it was 2 steps on this one. Oh, I've got 4 examples. I forgot, I guess, because I'm on another page. How about 5%? What would I do for 5%?
10%.
Fabulous. 10%. So what is 10% of 32? 3.2. And then Miranda said we'll divide it by 2. So what is 32 divided by 2? I'm sorry, 3.2 divided by 2. Yeah, it's 1.6, so $1.60. These are all dollars just because the numbers are given to us in units that are $1. Okay, now I'm shifting gears on you a little bit because D is different. So as you're looking at 25%, it kind of feels like it should follow along with the same things we've been doing. I could find 10% and I could double it, and I can find 10% and I can half it, and then I can add it up. What's the problem with doing that? It's too many steps. Are you guys with me? Like, I'd first have to find 10%, and then I'd have to use that to find an additional 10% or to take an additional 10%. And then I need a 5%, and then I need to add them up, so minimum 4 steps. You've got too many things that you're sort of holding simultaneously in your mind, because that's what mental math is supposed to be, is I can do it without writing it down. So we don't want to do this. Okay, so what do we do? Well, 25% has a very nice fractional form. What is 25% as a fraction? It's 1/4, right? 25% is 1/4. So if I want to find 25% of $84, instead of worrying about it in percent form, I can do it in fractional form. And 1/4 of $84 is very nice. So what is 1/4 of 84? It's the same thing as asking what is 84 divided by 4? It's 21. So either of those versions are going to give you 21. Now pause with me for a second and consider, could I have done something different like that as well for 20%? I actually could have. It might not be the most natural approach, and you might not think of it, but because I mentioned this one now, you could take 20% and turn it into its fractional form. Now, it's not quite as easy of a fractional form, like it's not as convenient as the ones we've seen before, but what is 20% as a fraction? It is 1/5. So you could have done 1/5 of 280, especially if the number were not maybe 280, maybe it'd have been 250. That would be nicer to do 1/5 of, right? 280 is not quite as friendly, but it would be an option, right? It would be an option to change 20% into a 1/5, just like my 25% changed into 1/4. Okay, example 7. We touched on this briefly last time about it being possible, but we didn't really talk about why necessarily. Why is it possible to have an increase of 150% in price, but not a decrease of 150% in price?
Because you can't go below 0.
Yeah, a decrease of 150% would actually be going below $0. What would it take for it to be $0? Yeah, if you decrease 100%, it would equal 0, right? So if you decrease 150%, it would actually go below. Why is it okay to increase then 150%? Yeah. And I want to focus on the word add that you mentioned. When we're talking about increasing, we're talking about adding things. Like, I can continually add to something, right? We can continually add. But to take things away, there is this sort of a limiting point, and it's 0, beyond which I can't take anything away because this is money we're talking about, right? You're not going to go to the store and Walmart's going to pay you money to take food away. Like, that doesn't work that way. On an anecdotal point with coupons and so forth, there are ways that it can work that way, but that's very atypical, and that's not quite what we're talking about here in terms of percentages. So the issue is we cannot decrease over 100% because a 100% decrease means we pay $0, or you could say it's free. But we can increase let me say it that way, by more than 100% because we are adding to the price. Right? We can do that. All right, the last set of examples in this section have to do with interest and percentage increases in a slightly different way. So that are like interest. So the interest in this section is all simple interest. So we're not doing compound interest. The reason is because compound interest is a topic that shows up in an algebra course, which is outside of the elementary curriculum, right? So that's algebra. It hits 9th grade, and that's outside of where you guys are certified to teach through. So they stop with simple interest here. So let's do some details about what we're talking about. Interest is simply the amount of money you pay or earn to borrow or lend money. Principal is the original amount of money that's used to determine interest. So it's the amount that you borrow or the amount that you invest. That's what it is. The interest rate is the percent that is used to determine the interest. And then there's two formulas, very related formulas for simple interest. The only difference in those formulas is whether you distribute the P here through the parentheses or you leave it as a multiplication in front. And one's not right or wrong, they're just different looking. And in the formula above, this piece right here is the interest amount, not the percent, but the interest amount. So if you have like a checking or a savings account where they give you interest, it's usually a very minimal amount, right? But every month or maybe every quarter, every 3 months or something like that, the interest is the additional amount that shows up in your checking account or your savings account as the additional amount put in. But it's based on how much money you've had in the account during that time frame, how long that time frame is, and what the interest rate is, which is exactly what it shows here. P, how much you have in the account, R is the interest rate, and T is the time. It is really important to recognize that the time here is time in years. So keep that in mind. Anytime they're talking about the time is in years. And the rate is as a number, not a percentage. So if they give you, 5%, you have to turn the 5% into its corresponding decimal to use it in the formulas. Okay, so let's do an example. A company is expanding its line to include more products. To do so, it borrows $320,000 at 13.5% annual simple interest for a period of 18 months. And the question they ask us is how much interest will the company be charged? So if you look back over here, I've got 3 equations given. Which one will I use or is most directly usable to find what this question is asking for? We'll call them 1, 2, and 3. Which one is the most easy to use? Yeah, 3. 3 is the most direct. You can actually use any of them, but 3 is the most direct one to find because it specifically finds interest, and interest is what I'm asked for. So I'm asked to find interest. So this is I equal PRT. I is what I'm looking for. What is P in this particular problem? Like, what is it? What number?
13.5.
Nope. Good try. We're going to use that one in a second. Yeah, P principal is the amount we loan or borrow. So this one is the $320,000. R is going to be related to the 13.5, okay? So R is the interest rate, but 13.5 is a percent. Whoops, I meant 0.5. But the R that goes into the problem needs to be the decimal version. So what is the decimal value that's associated with the percentage 13.5? We talked about changing percentages last time. What's up?
0.135.
Yeah. One way to change, especially when it's already in a whole number or a decimal form, is to move the decimal 2 to the left. This gives me 0.135. So the rate, the R, is 0.135. In a very real sense, we're also asked to put in time. So the time given in the problem is 18 months. But the time that I put into the formula needs to be in terms of years. What is the year number associated with 18 months? 1.5. Yeah, it's 1.5. 18 months is 1.5 years. So if you grab your calculator and you multiply 320,000 times 0.135 times 1.5, what is the amount of interest that this company will owe to the people who are borrowing their money from? $64,000. Say 800. Yes, 64,800. Okay, so we have time for one more example. We'll do the one more example today. We're going to call it good when we're done with that. I'm going to leave the group work and the homework both to be done for Friday. I will actually finish the example number 10 in class. Nothing hinges directly on it, but I do want you to see another application of these percentages because it's a really nice one that was directly affected by you. And if you take a look at example number 10, it's about what? All the caseloads of COVID-19 from back when you were in high school, right? Were you guys all in high school then? That's right? Still in high school? 9th grade? 10th grade? Where were you? 9th? You were a junior? Okay, so you're in high school. So we'll talk about that one next time. But let's take a look at this one. This one's a really nice application, and it's shown up in some version of it on standardized tests when people have done OSATs and such. So just so you know, things like this. So it talks about because of a recession, the value of a new house depreciated. That means it went down in value 10% each year for 3 years. And then for the next 3 years, the economy begins to recover and the value of the house increases by 10% per year. The question that's posed is, did the value of the house increase or decrease over the 6 years? So when you just look at this sort of at a gut level, it looks like it's the same. It went down, went up, same percentages, should just be sort of evening itself out. And I will tell you, percentages don't work that way. The other thing that's really tricky about this one is it doesn't tell you how much the house was worth, does it? Okay? So when you're given information like that, what you can do to find the answer still is to just make up the amount of the house. It's very nice. So we're going to make up a convenient number, even if it's not a super realistic number. I'm going to use the number 100,000. Good luck finding a $100,000 house these days. They're there, but they're few and far between, kind of. But it works really nicely for our calculations, so we're going to use 100,000, and it doesn't really matter. So we're going to assume a $100,000 house. Okay, so year one. At year one, it goes down 10%. What is 10% of 100,000? What is it? Somebody said it. 10,000, yeah. So it's going to take, what we're going to do is we're going to take our 100,000 and we're going to figure out what 10% is, and we're going to subtract it off. Now, there's an easier way to do that. What we can actually do instead is we can talk about it being worth 90% of what it was before. Okay? So instead of doing 10% and subtracting, I'm going to do 90% and I'll have my answer directly. So if I take 100% minus 10%, I have 90%, right? That's where that 0.9 is coming from. It's 90%. So if I multiply this, I have now a house that's worth $90,000. Does that make sense? Okay? Good. Year two. Well, the same thing happens again, but I don't start with a $100,000 house now. The house is no longer worth $100,000. It's now worth $90,000. But it loses another 10%, right? Which means it retains 90% again. And you can use 0.9 instead of 0.90 if you'd like. So what is 90% or 0.90 or 0.9 either of 90,000? $80 something. 81. Okay, so if your calculators, they're handy. If you multiply 90,000 times 0.9, it's an $81,000 house. Why didn't it go out in $10,000? Because it's not 10% of the 100,000, it's 10% of the 90,000. Are you with me? 10% of 90,000 is only 9,000. That's why I went down 9,000 this particular time. Year 3, one more time of a decrease, but now it's worth 81,000. And it's going down another 10%. So I take my 81,000 times 0.9. What do I get? 72,900. Excellent. Years 4, 5, and 6, what happens? It increases. So this next year, the year 4, the 72,900, instead of it going to 90% of the value, it needs to go up. Okay, so instead of 100% minus 10%, I want 100% plus 10%. So if I do 100% plus 10%, what do I get? 110%. And as a decimal, this one was 0.90, this would be 1.10. 100, 10%. So we're going to do times 1.10. And we're going to do that for all 3 of our last years because it goes up 10% in each year. So I'm going to kind of jump to where we are with these numbers. This is 80,190. And then I get an 88,209. And then I'm rounding to whole numbers for the purposes of what we're doing. And then I get 97,030. So the house started out worth 100,000. After 6 years, the house is worth 97,000. Did the value of the house increase or decrease over the 6 years? It decreased. This house decreased in value. Now, what's even more interesting to note is that if it did it in reverse order, the reverse would happen. If it increased the first 3 years and then decreased the second 3 years, you wouldn't necessarily end up with the same thing. Things look a little different. So just beware of that. But how much did it go up or down? Well, here we just used an arbitrary number to decide did it go up or down. But the process by which we can figure out the percentage actually doesn't matter on the value of the house. So how much did this house, the way we set it up, go down in value? Well, it was 100,000, and now it's worth 97,030. So how much did it go down in value? How much value did it lose? 2,000 something. 970? Does that look right? Okay, so this is the value lost with the numbers we made up. We can actually find what percent it went down. We'll do this real quick. It went down $2,970 out of the value of the original cost of the house, which is the 100,000. And we can figure out what that percent is. This is like what we did last time. We did an example much like this with our softball price, right? Where it went up or down. I think our softball price, we were looking at a sale. And if you cross multiply these, you get 100,000x equals 2970 and then a couple more zeros. If we divide by 100,000, then we end up getting a 2.97%, almost 3% price. So it decreased almost 3% in the price of the house with these conditions over that span of 6 years. Okay, so homework, group work for 7.4 are assigned and will be due next class period, okay? I will finish the rest of this example and do questions at the beginning, and then we will do review for the test.